I'm Tim Kington, and this is Coding is for the Birds. Today we're going to be working on the JVM, and we're going to try to add support for the double type. That's going to be interesting because they're 64 bits wide, and everything we've done so far is assuming that we're working with integers. So let's dive in. I think the next thing I want to try here is to use a double. And first we'll do a little math directly with doubles, and then maybe look at type conversions. Eventually we're going to have to be able to handle that. So let's try adding a couple of doubles here. And see what we end up with. So we're going to hit some new opcodes, I'm sure. Okay, so we have a constant type 6, so that's probably a double constant that we're going to have to handle. That's in parser. Right, const double is 6, I guess. I suppose we should check the VM spec just to be sure about that. So 6 is constant double, and it's going to have two 4-byte fields here. All right, so let's handle that. Case here. We'll return a double constant. And let's add a redouble here. I'm actually not sure this is what we're going to want to do, but we'll have to check. I guess, yeah, having the double as a double in the constant is probably right. So I think we're not going to log this one. So I'm probably just going to read the double. And we'll go on from there. We need a double constant. I think we probably want a new package for constants, maybe. Let's move all of this stuff. And we need a new one. Push, and we need a value. And I guess we want a constructor. And so far we don't know how to push the double onto the stack. Oh, these take up 2 entries in the constant pool table. Well, that's very annoying. Yuck. Okay, so I guess we need to increment the counter twice here. How are we going to do this? Read const info. Yeah, they're right. That was a mistake, huh? I don't know that there is a nice way to do this. Maybe we need to... I guess we'll make our constants... Okay, that's already a member of the class. We're not going to add these here anymore. We'll do it in read const info. So it will add it here. Yeah. Yeah, okay, so wait, we're going to want to do this for all of these at once. So and then they all need a break. Okay, so that's fine. And then when we hit the double, we're going to have to add a dummy entry here. I guess we'll make it a string constant. Not real. That's kind of terrible. What's it unhappy about now? Has to return the constant. Yeah, we don't need to do that anymore. This is void now. And then we also need to update our index, right? So the index here, I guess we're going to say just while. Yeah, this just becomes a while. That's kind of wacky. This 2 for 1 is very bizarre. Okay, so now we still don't know how to push our double onto the stack, but I'm not going to worry about that at the moment. I want to see what the opcode is that's going to use the double, and maybe that will tell us what's up. Okay, I guess not. All right, let's see what happened here, maybe. We got our constants. We have 27 of them. Those look pretty reasonable. The last one was source file. Okay. I don't think that's right. Source file. Source file is not the last one. app.java is the last one. So we... Oh, right. I know what it is. This off by 1. So they messed up a couple of things in the constant design, I'd say. So this needs to be... this needs to not be added. No, it does need to be added because the indices are 1 based. We need to get rid of this -1. Yeah, okay, so that's probably going to take care of it. Okay, now we got an unknown opcode. That's what I was expecting. So it was 14 hex. Okay, so we need to get the double from the constant pool and put it on the stack. And I guess we need to figure out what that looks like. So, okay, operand stacks. Each entry holds a value, including long or double, and then a long or double contributes 2 units to the depth of the stack, and any other value contributes 1 unit. So I guess that's what we want to do. We basically want to push the double as 2 32-bit values. So in double constant, we need to convert our value to 2 integers. There must be a method in double somewhere that we can do that with. Double to long bits, double to raw long bits. What's the difference? This preserves NaN values. I guess we want that because we can work with NaNs in Java probably. So we'll do that. That's going to give us a long. And then we need to push the pieces of this onto the stack. So probably doesn't matter. I doubt the VM spec is going to treat the 2 parts separately ever. So I'll push the high part and then the low part, I guess. So we'll say int of raw value right shifted 32 bits. So that should give us the high part. And then the low part will be raw value anded with I guess well, do we even need to do that? I guess maybe we don't. Just int should do it. All right, so I think that's going to do the trick. So our opcode 14 needs to work a lot like the other one that's pushing a constant, that LDC. Yeah, so here we need a case for 14. Our constant index back here is 2 bytes, so we're going to say int const index. This really could be a short, I guess. Read short. Might as well call it a short. And then we're going to create a new load const opcode for w const index. I'm not sure we really need 2 different ones here. This thing already took an int as our const index. The reason they seem to have 2 different opcodes is because, first of all, the index into the constant table can be larger, and they're doing something special to push the double, but we don't really do anything special because our constant object just knows how to push itself. So this might be okay. We're probably going to hit another opcode we don't know. Okay, 48. It's probably our double add, double store. Yeah, okay, double store. Local variable array. Apparently they're using 2 slots in the local variable array to store doubles too. I don't think that we care. We can probably store it at index n, and that'll be all right. So dstore is going to look a lot like our istore. Where's that one? Yeah, this ran from 48 or 47 to 4a. So here we'll say minus x. Got this wrong. This is 47. And then opcodes. And I guess maybe I'll make a new opcode just in case we have to break this out later. Let's live dangerously. See what happens here. Okay, then we hit an opcode 27. Is that real, or did I run into a problem of some kind? This is probably a double add. Oh, it's a deload. Okay. 26 to 29 is deload. These are out of order. Maybe we should rearrange these a bit. Just to make it easier to find things. Var index. And then is this really going to work? I don't know that this is going to work. What are these doing? Yeah, this really doesn't work, does it? I guess we're going to have to use that. We can use the local var as being 2 slots of integers, so we need to really do this. All right, so dstore is going to be a dstore opcode. deload is going to be a deload opcode, and then we need to really implement these. Index is right. This part's okay. Now here we need to be careful. Now our stack.pop, so when we pushed it, we pushed the high and then the low. So I think here I'm going to store these in that same order just to make it easier to remember what's going on. So local vars at var index is the high part of the number. And then we need a deload opcode that's going to look a lot like this one. So we need to do this and get to imports. And then we want to push the high and then the low, and we decided that the high was this one, so this part's okay. I guess this will probably run now. Nope, we've got another opcode we don't know. What's that going to be? 63. Is that going to be the double add? It is, dadd. So here we pop the values off the stack, and they're going to each take 2 slots, right? So 63 is dadd. Execute. And now our execute's going to have to reconstitute 2 doubles. So we're going to say low's on top of the stack, right? So low 1 is stack.pop. High 1 is next. And then we have low 2. And we'll have high 2. And actually, we're going to need to do this many times, so this is the wrong way to go. What we really want to do is probably add a utility method to opcode. And do it here. So it's low 1, stack.pop, just low. High is stack.pop. And then we need to put this into a long. And we need to left shift high, but I think we need to convert it to a long first. Long of high, left shift at 32 bits. And then we OR it with low. And then I think that's the right value. So we're going to return double dot. Do I have to set default here? right, so we have this pop double, and we're going to use it in our d-add. Right. That's fine. And then we need to push the result. This is going to convert in the other direction. So do that, and then we're going to push the high part, which is right shifted 2, and then we're going to push the low part, which is just int of value. And this needs to be converted to an int. And this is void. And then our push double here, we need to pass the stack. And the result, what other problem do we have? D-add opcode. That's just because it hasn't been imported yet. Okay, so we might be ready to run this. This time I definitely want to look at what's going on in each of these opcodes because I'm not sure that this is going to work correctly. Opcode 39. This is a D store with an index, so index is a byte. So this is a different D store. Okay, so we got to an execute for a D store. Our local vars have zeros everywhere. And our stack has some integers that look fishy. So we missed where the value is getting put on the stack. And this isn't going to work out correctly. So we're going to get an add, and we're going to be adding like totally bizarre values. Yeah, this isn't right. So what did I skip in the translator? It's the load const opcode. Maybe, yeah, this one. Well, maybe we need to look at what happens in double constant. This is basically the thing I skipped, I think. Okay, so we're going to push a value, and it's 1.11. So we get our raw value, which seems, I don't know, pretty reasonable, I guess. And then this is going to push a 0, isn't it? No, it pushed this value. Let's push the same thing twice. So this can't be right. I think here, I don't want to convert this to an int and then right shift. That's a problem. So we need to right shift first. So I think that's probably bad. Let's see what we got now. Well, at least we have different values on the stack. Maybe that's better. And now we're going to pop them into our local vars, and now we're going to convert them back. No, now we're pushing another double. Okay, so this one, we'll add 2 more numbers to the stack, which those appear to be different. And now we're storing a double into a value. And now we're loading it back. Okay, now we're getting a pop double stack, which we're hoping. Okay, it came back as 2.22, so that looks like it worked. We got a 1.11. We push that double onto the stack. And now we're going to store it into a variable. And this time, our local variables are kind of confusing. It's hard to tell if these are right, but from stepping through the code, it looked like they were. So I think we're going to call this correct for now. Yeah, correct. So all right, let's do a test for some of this double stuff. We'll call it dadd, I guess. We're going to want to get something out of our constant pool. So we need to do this, load a double from our constant pool onto the stack. So it's a 14 followed by a short. This will be a 14 and then a 0 and a 1, which should get us our first constant. Go ahead and create our constants here. And then we need to add double constant with our value. I guess we'll call it 1.25. We want doubles that can compare exactly, I guess. Yeah, so just to keep things consistent. We'll do that. Okay, so our double constant 1 got loaded. Now we're going to do a dstore, which is here. Dstore into local 0 should be a 47. So we'll do a dstore 0. And then we also want to be able to load and add them. We can go ahead and load the same one twice and add it to itself, right? So first, let's just test our dstore. So we'll just go to this point. And we'll go ahead and run this. And now when we get to the end, we're going to need to check some doubles. So I guess I can put the double pieces into the array myself. That's probably what we should do. So here's our value. And then we're going to split that up ourselves, I guess. So double to raw long bits of val. And then this will be we'll say high and low or something. High is raw val shifted 32 converted to an int. And then low is just int of raw val. And when we put them into our local variable array, we should get high, low. Okay, let's see if this works. Okay, constants is null. That makes sense. I should have put it here. Okay, Okay, it passed. So that did our D-store. So we loaded something, and in the constant table, it was a value of 1.25, and then it got stored here, and it matched our 1.25 the way we wanted it to be. So that's good. Now, the other thing we haven't tried is a deload. So let's do a deload and a destore here. Our translator deload is 26 for deload 0. We'll do a deload 0, and then we'll do a destore 1, which will be a 48. And now we should have two locals with the same value. Two locals here. Okay, and then high, low. And we need to change max locals. I just want to see this fail. This button is broken. I don't know why that button is broken. Okay, range index out of bounds, good. So that's actually mattering what we pass to max locals. We need 4 locals because, oh, and this should be a dstore 2 because it's going to use 2 slots, right? So we need to use 49 here. Yeah, I think that's right. Okay, and it passed. So we should run everything, make sure we haven't broken anything. So we're in pretty good shape here. I think we did have one more new opcode. Yeah, so this was a dstore also. So dstore with an index is 39. So let's go ahead and make sure we're testing that too. So we'll do a deload. We might as well do a deload 2 just to make things interesting. It doesn't really exercise new code. What was the number? 39. And the index is a byte. So OX39. And if we're going to store it in 4, this is a dstore 4. We need 6 locals now. And this should be, again. Still can't do it. It changes this to 0% every time, but it doesn't run the test. Okay, passed. So I think we're good to go here. We've got a dstore, a deload, and a deadd, and they work. So now doubles are working. I'm not sure I like all the design choices I made there. The new methods that we added to the opcode interface might not really belong there. I'm going to let some of this stuff grow a little more before I decide how I want to organize it. Next time we'll take a look at casting. We'll convert from a double to an int and back and see how that goes. Thanks for watching. Don't forget to like and subscribe.